Okay guys, Ron here. We're looking at this problem today and the data shows the wait time for 20 patients and the management just started a new system that is expected to change the wait time. We're asked to test the hypothesis that the wait time is still 36, that's the null hypothesis, against the alternative hypothesis that the wait time is different from 36. So the data is here. We are going to do some manual calculations in Excel. If you click on this cell here, it's showing that we're calculating the mean wait time for the population, not the population, for the sample, and the sample data is here. So we do use the average function in Excel to give us that, and I've sort of shown it here, but if I didn't, you could click on the cell and look in the function box here to see how I came up with the information. If you click on this cell here, again you see I'm using an Excel function to calculate standard deviation, and then standard error is related to standard deviation by dividing the standard deviation by the square root of the sample size, which is what I'm doing here. It's G6, which is the standard deviation divided by the square root of the sample size, which I've just used a count function to calculate. Then we know we're going to be using a t-distribution. So the t-value is calculated by using the confidence level that we're looking for, which is 95%, so it's 0.05. And the degrees of freedom is 1 less than the sample size, which is 19. So we get a t-value of 2.09. So the next step is to calculate the upper and lower limits for the confidence interval. And why are we interested in that? Let's just look at something in the text. The confidence interval is the range within which we expect a true population value, for example a mean, to lie. So what it's saying is that if we generate a confidence interval and the null hypothesis expected mean is within that, then the null hypothesis cannot be rejected. However, if it is not, then we can. So how do we calculate the confidence interval? Again, let's pull from the textbook, because I want to relate what we're doing to the text so you see where I'm pulling information from. The confidence interval, the limits are going to be calculated by calculating the mean plus or minus the t-value times the standard error. So that's essentially what I have done here. In this cell, it's the mean plus the t-value times the standard error, and in this cell it's the mean minus the t-value times the standard error. Now, what information does this produce for us? Let's take a look again, and forgive me for consistently going back to the text, but I want to show you how it relates to what you have in terms of material. So if your confidence lower limit in this case in the text was 43 and the upper limit was 47, the value for the null hypothesis was 48, is no longer contained in the confidence interval that the nurse has calculated. So as a consequence, from the standpoint of hypothesis testing, she would reject the null hypothesis. So we reject the null hypothesis if the value for the null hypothesis was 48, which means that that's what we're testing around, and the interval that we got does not include 48. It means that the null hypothesis is going to be rejected. So that's the background, and this is on page 248 of your text if you want to get a little more background behind it. So in this case, the null hypothesis is referring to 36 and it's not within this range, so therefore we would reject the null hypothesis and accept the alternative that the mean wait time is different. Okay? A quick example I just wanted to do, I'm gonna fiddle with the data a little bit here just to be able to show you what the difference would be if we had data that produced a situation where you would not reject the null hypothesis. And this is made up data, so don't pay too much attention to it. But if this was the data we started with, and Excel will automatically recalculate your range, the range has now changed to be from 34 to 36.99, which now includes 36. So if this was the data we started with and we got this confidence interval, then we would have to change this conclusion and we would not reject the null hypothesis. Alright, so if this was the case, we would not reject the null hypothesis. And I just wanted to show you that real quick so you could see what the two options are. I'm really hoping that this makes sense to you. The possibilities are two. When you get this range, one of two things can happen. The null hypothesis value can lie within the range, and if it does, you do not reject the null hypothesis. However, if the value for the null hypothesis is outside of this range, as it was when we first did the problem, then you would reject it, and rejecting the null hypothesis means you're accepting the complement of that, which is the alternative hypothesis. Alright, so if you have any questions, feel free to send me an email. This is Rohan, and thank you for watching.